recovered yet. So hopefully the next one is fully recovered. The main problem is after I'm taking Tylenol, it looks like sometimes it's dreaming. So I do not know what even, I don't understand what I'm talking about. So, so it's going this way and this way. So, but maybe next week it will be much better. Okay, so this is our computer. And it's an electronic device. Definitely we need the power. So what happens when you plug it and start plug in the power, then start the button? What happens in the computer?
Shut down.
Shut down? It's a start. It's a booting up, right? Then the more detail. So when you give the power, what's going on inside on your computer?
The OS is loaded.
OS is loaded. Before that, there are a lot of things that happen. Anything? So long time ago when I purchased, so I like to use the Linux as well as the Windows a long time ago. Right now it's very simple. You can purchase the VMware or the virtual machine. Then you can download the images. Then you can run. While you are running the Windows, you can run the Linux, and it's not a problem. But a long time ago, it was different. So there was no the virtual machine concept. So I need to install the two operating systems in the separate the partition. Then when you start up, we can select the operating system, which means there might be a lot of the steps before we start the operating system. So first thing is, so when you give the power, this is an electronic device. So computer, this electronic device should know what kind of the device are connected. Like the hardware, what is the hardware, and where is the CPU, and so on. You need to check the connected devices. So who is in charge of them? And so there is a BIOS program. It's also operating system. Its name implies it's a BIOS. It's an operating system. There is a small, tiny operating system. Okay, where is that? It's RAM. RAM is the volatile. It's gone. Instead, ROM. So it's on the ROM or sometimes the EPROM. So it's anyway ROM, which means this is the firmware. The firmware is a software that resides on the device. Okay, it will not be, usually it's in the ROM, the read-only memory, so it will not be gone. So first, the BIOS program is checking what kind of device are connected, what is the memory and what is the CPU and whether it has the USB and so on. After checking all the devices on your computer, then another important task of the BIOS. Do you remember nowadays not many students are using such a functionality, but if you while your system is starting up F2 or the F5, F8, if you type, then you can see the BIOS program. Then you can select order of the what? Boot. Booting the order. Booting order means, so eventually our goal is starting up the operating system. Okay, so without operating system we cannot use the hardware, the resource. So your operating system can be here A and B and C and D. So in the BIOS program you are able to select the specific operating system. Because of this one, the long time ago there is a software, even there are still. So if you firstly start your Windows, the Windows sometimes give the option whether you are going to start the recovery operating system or the normal operating system or the Windows operating system. Similarly, so there is the others, the similar program, anti-loader or the redo or the anti-loader. You can select the specific operating system. It's a software. Okay. So similarly, the BIOS program. In the BIOS program, you are able to select the location of the operating system or order of the operating system. So which means check the A first, whether A has the operating system or not. If not, then next, until you find the operating system. If you find, then this partition will be the new BIOS program, direct to go to that partition, and there is a master boot record MBR. So this MBR has the address of the operating system. Then what happens after you find such an operating system? So start
that particular
Start operating system means what?
execute
Execute, load. Everything is the same meaning. Eventually we need to create the first process. So anything. So if you want to do something or anything or whatever you want to do in your computer system and using operating system is through the process. Process is the data structure that can be ready in the memory and use the CPU. If you remember what we discussed the last class, the CPU and memory is everything in the computer. So CPU eventually will use the data in the memory. So same thing, to utilize the hardware resource. So we need to use the first process. This is called kernel process. So the kernel process will be starting the first process, which means it's the same as any other process. Like I create the A.C file and compile A.out, so I run the A.out file. What happened? This A.out will be loaded into the memory, then this will be processed. It's the same thing. Kernel is the compiled, but it's a little bit different way to compile the kernel process. But after you compile, this is the first program to be run. Then this will be loaded into the memory. Then this kernel process has the minimized core part of the operating system. You are the system to run your system. Mostly, kernel will create other processes. After we load the kernel process, all other process will be created by another process, which is called the parent process. So for example, this one create the swap, and this one create the network, and this one create something virtual machine and other thing. Okay? The functionality that we are going to discuss throughout the semester will be part of this one. So for example, I add a new functionality in operating system to manage the security. Then you can add this one as a part of the kernel. Then you can rebuild your kernel. Then the library will be called and start another process. And this one will create, for example, another process. Then finally you will have the desktop on Windows or the shell program. We will see what is a shell program later. Then this process, this after create all the processes, then you are ready to use the computer resource that is done. So this is what happens when you plug in your power and in your computer. At that time, what is the operating system? Even this one is the operating system, but we are not going to consider this as a part of operating system. This is a more firmware, hardware part. So if you are from the electrical engineering, so you should know such a thing. But from time to time, your BIOS program should be updated also. But in the operating system. Somebody consider this is the operating system. Kernel is minimized. Okay, so kernel is the operating system. On the other hand, somebody believed all of this until you start up and be ready to use your system. So that is the operating system. It doesn't matter what is the real definition of the operating system. So anyway, because of this one, the Microsoft actually include everything. Explorer, File Explorer, Internet Explorer. So there might be the rules in the EU, the Europe. So whether this is the legal, the Microsoft include as a default browser. So why not? Okay. So they believe, the Microsoft at the time believed that all of these are the operating system. But somebody believed only the kernel is the operating system. But it doesn't matter for me. So for us, so what is the really definition of operating system? But the more important thing is what is the functionality of this operating system. So what is the operating system? That is the main question of today's class. So operating system, as you can see, this is a software. Just like it's the same mechanism. So after we discuss about the chapter 3, the creating process. So creating, in terms of the creating process, creating kernel, operating system, creating any other process, is the same mechanism. Then what is the different thing of the operating system? First, operating system is a set of software. It's a software part. It's not hardware. So we are not going to deal with the hardware, not the device program. Instead, it's the software part. For what? Our main goal is to utilize such a computing resource. Okay? Unfortunately, these resources are limited. How many CPU? One or two? Do you have the unlimited CPU? It's not possible. So CPU is limited. The memory size, even though you have the 32 gig, the memory size, mine is 8 gig, so it's still limited. So nobody is satisfied with the size of the memory. Every time, everybody complain that my memory size is not good enough. The reason is that because we cannot load all the process at one time. Okay? The number of process increased is huge. So we cannot put the order, which means we need to in and out. Okay, later we will see that in and out, which is called the page in and out in the memory management. So limited. And also file system. File system is, even though this is much cheaper than the primary storage, but still the size is limited and the number of files are limited. So we have the very limited resources. So our goal is from the user point of view, we'd like to maximize, we'd like to use all the hardware resource, like the unlimited resource. But from the hardware point of view, the hardware, the computer cannot accommodate all the user requests. Then we need something in between to coordinate. Okay, to coordinate the user request, to allocate and control the resource. That is the main part of the operating system. Okay, so we cannot accommodate so create the process everything. But since we do not have the unlimited resource, there should be the control and the coordinate. Okay? That is the main job of throughout the semester. If we are talking about the CPU creating process, then the CPU resource is limited. So how to maximize the CPU utilization? That is our goal. And because of that, we need to do something scheduling. Okay? And also, some of the resources are shared. So this shared resource is shared by the processes. There might be a problem because we are sharing the resource. So how we can coordinate the shared resource, like the synchronization problem or the deadlock issue. And even the memory management, it's the same thing. I/O management is the same thing. The operating system is kind of a coordinator in between the hardware and the user request. In other words, when you are asked to develop the operating system, okay? So main job is not just the algorithm or the such a thing. First, you need to analyze what is a really user request and how much you can the support such a user request. So it's unlimited or the limit by what, and then finally by considering the user request and the hardware resource power, then you can control such a resource. You can design and develop your own algorithm. That is the main job of the operating system. Okay, so that is the overall thing, what we are going to do in the operating system. What is operating system? There are many different. So first, we talk about such as computer architecture, including hardware and the user, and the operating system is in between. Sometimes it's not very clear to divide the operating system and the application program. Nowadays, many of the operating systems include a lot of application programs. So you don't have to be serious what is really operating system, what is the application program. But one of the interesting application program is database. So I'm teaching the database class also. Before that, the database application is a DBMS, like Oracle, Informix, DB2, Sybase, SQL Server. They are the application program. However, some functionality in the DBMS can do exactly what the operating system is doing, like the memory management, process management, and the transaction control. So nowadays, it's not very clear between the operating system and the application program, but it is true. It's kind of a trend that tends to minimize the functionality of the operating system. Okay, then give the flexibility to the application program. However, in terms of business like the Microsoft, they try to keep more and more application program as a part of the operating system. That conflict many times. Okay. So from the diagram, you can understand what is really the operating system. Operating system deals with such the computing power from the versus the user request. Okay. So this is the clear definition, which I like it. So OS is the resource allocator. Okay. So as I keep saying, if we have the unlimited resource, our operating system textbook is very simple, and it will take just a couple of weeks to learn the operating system. But since we have limited resource, the operating system should be the allocator of the resource and definitely control. And in other words, is coordinate such a request. So that is but some of them argue the operating system is everything that ship with when you order the operating system like the Microsoft. But this is the kind of trend. The kernel is the only operating system is minimize the operating system, then give the more flexibility others. So I like this definition to define what is the operating system. There is a program. That is true. It's a software that control and coordinate the use of hardware resource among the various computing programs. This is a request by the user, okay, for various users. So it's a control, coordinate, and resource. Okay, resource means the computer resource include hardware, and sometimes some of the software they provide as a data structure can be the resource also. And the control and the coordinate. So these two parts is the main part of the operating system throughout the semester. So we will learn a lot of the algorithm and approach to how to control or how to coordinate the user request. Okay, and this is also considered as the operating system. It's a small, the BIOS program. So it's also the operating system, but it's a firmware. So we are not going to deal with as a part of the operating system, but it is the main electrical engineering should deal with such the firmware, like the bootstrap program. Then, once we have the so what is the research of the computer, as we discussed before? The CPU. But unfortunately, the CPU is very limited. Think about the single core, the single CPU system we have. Then this is the CPU time. So at certain time, only one instruction will be executed. However, how many processes are running on the system? Many. So if you take a look at your task manager on your laptop, so probably the 50 to 100 processes are running simultaneously, which means they are competing. They are fighting to get the CPU resources. So definitely the operating system coordinate to this one. Then, this is one of the examples. So in your program, so I'd like to open the file, fopen, the a.txt file, and the read and write, and the read, fread, the data. Okay, so probably this will be changing the instruction, which I do not know. I cannot remember, but you should know the assembly language. But this code, when the CPU process this one and finally read the data from the open, then read the data. What CPU can do? Actually, CPU cannot do anything. Why? You are reading the file and read the data. This one actually goes to the hard disk drive, then read the data and return back. The CPU should read the wait. Okay? So at that time, we can switch this process to another process while the CPU is waiting for the reading, and this time we can switch it to another process, then we can maximize the utilization of the CPU. So that is called the CPU scheduling. We will discuss later. But in this time, what happened? So I read the data. So when you read the data, how the CPU can request to read the data from the hard disk drive. And also, what if the hard disk drive read the data and inform to the CPU operating system? How? So at that time, we need something, the agreement in the operating system. That agreement is based on the interrupt. Interrupt means it's an interrupt. So you can interrupt my lecture anytime if you have any question, right? So feel free to interrupt my lecture if you have any question. Similarly, the operating system and each device, they do not know what's going on. Whether you read the data, whether you request the data, then instead, the operating system uses interrupt. Interrupt is kind of a signal, like to raise your hand. So if you raise your hand, I stop my lecture and give the chance to you to ask the question. Okay. Similarly, the operating system, current operating system, communicate each other. So first interrupt, then ask to the it's a controller. Disk controller, then I need the a.txt file to read the data. Then continue their work, and after the disk controller read the data and ready to back to the memory, such as the ABC, the data after read, return. At that time, the interrupt, the operating system stop. which means interrupt the most important resource of the computer is the CPU. So CPU should be stopped. The interrupt, then the copy the data, then operating system realize. So nowadays, the current operating system is based on the interrupt. So there are different types of interrupt. So for example, the hardware, like this one is a hardware based. Each the controller has the interrupt signal and then stop and continue. So hardware interrupt. And another one is the software interrupt in the programming. You can stop the CPU time, then the continue. Like the, for example, divide by 0 or the divide by 0 is a trap. So another software, the interrupt, the software level, you can do the interrupt signal. Another one is, the third one is sometimes part of the software, but it's called the trap. Trap is the exception in your, for example, Java programming. So when you read, when you open the file, if you cannot open the file, you can raise the exception, right? Try, catch it, and the exception. It's the same thing. So we can make the trap of the something for exceptional case like the divide by 0. In case of the divide by 0, that is the first actually the trap code. So then it's the same thing. Give the operating system the signal. I cannot handle the divide by 0. Then do something. So which means the operating system nowadays is based on the interrupt based. So using the interrupt, so there are different types of the interrupt number, which is managed by interrupt vector. So interrupt vector is in the memory. In the memory, for each interrupt there is a code to do. So in case of interrupt number 0, do something. The interrupt number 1 and do something. It's the operating system should manage such an interrupt. So nowadays the operating system is based on the interrupt. So that is an interrupt-based current operating system. We will see the more details when we talk about the I/O management, the interrupt. Okay, so this is called the operating system is interrupt-driven, the operating system. The reason is that, the main reason is because we have a limited resource, okay? So since we have, especially the CPU time is just one, the thread of the time. So we cannot separate, instead stop and reuse, stop and reuse. Also at the same time, we cannot process the instruction 2, 3 instruction at the same time for the one single core. So because of that, we need to manage the interrupt. So there are different types of interrupt as I introduced. So hardware interrupt is from the controller or any hardware, and the software interrupt is the operating system generate. So such an interrupt signal, like the system call. We will see the more details about the system call the next class. So kind of the system level API. Okay, so operating system provides such a system level API, and the trap is the exceptional case, like the try and catch in the Java programming. So like the divide by 0 or the something incorrect use of the instruction. So this is a trap code. How it works is very straightforward. So for example, in case of something happen, CPU is interrupt. Then stop the current job. Current job means the save the current the address of the location of the next instruction on the PC. Okay. Then the program counter. Then the stop. That is the current stop the current process. And then disable the interrupt means it's the current job is the stop. Then the taking care the next one. We will see the details about the I/O structure later. About the storage structure is like the hierarchy. So which means this one fast and the smaller, and this one slow but cheap and bigger, like the register. And the memory, in between the memory and the register, there is also L2 cache. And then the storage, finally, the bottom one is the magnetic tape, like this. Then, what is a cache, by the way? Temporary storage? Faster? I think that you probably understand. Long time history of the computing. So whenever we encounter speed problem, okay, there are different ways to address such a speed problem. One is you can develop, improve hardware, okay, then the speed up, but it's limited, okay. Even though we develop the new, there's an understroke, so every 18 months it will be doubled up, but it's still limited. Another way to address the problem of the speed gap is the cache. Idea of the cache is, as you mentioned, if the data is frequently accessed, not all the data are accessed every time and all the thing. So think about the banking system. So it is true the only 1 or 2% of customer in a bank actually create all the 99% of the benefit of the bank. Like me or the normal customer actually do not create any profit for the bank. So is that only the top, the 1 or 2? So that is very similar in any other organization, any other structure. Like the classroom, so if you go to the Harvard or the Yale, not all students are very good performers. Some of them are good and the others are not, they are very poor performers. And the same thing everywhere. So it's not uniformly distributed. Always there are top and then the middle and the low. So in the data, the information or computer system, not all the data are the access needed. There is a rule like the 20-80 rule, so 20%, less than 20% of the data are accessed. Like think about your cell phone, how many times you see your photo? Probably not. Sometimes you realize that I never taken this photo, but you have it. So not all the data are accessed. So why don't we? Idea is to keep such a frequently accessed data in the fast medium. Okay? So memory is also kind of cache. That is from the secondary storage. So not all the data are needed, only the few of them, the frequently accessed to the memory. Similarly, in the L2 cache, so instead of accessing directly the memory, some of the instructions are frequently accessed. So why don't we keep such a data in the cache? So cache approach is used a lot in any computer, the system, and any application. For example, the database use the cache a lot. So if you need to insert the Oracle database, so at least 4 GB memory are requested. The reason is that they need a bigger size of the cache to speed. Okay? So they cannot speed up to access the data. It's limited. There's upper bound. So to address that, to get the benefit of the cache. So cache used a lot in the storage and the I/O. The operating system also used such the cache. Okay?